So hello viewers and welcome back to another video on networking. So in this video we are going to start the new series of protocol learning where we'll see the DHCP protocol. So in this lecture we'll cover the very basic overview of DHCP, how it works and its introduction. So without wasting much time, let's get started. So as usual, we'll follow the content in this format as we have been following for so many videos on our channel. So by the way, last series was all about ERP protocol. If you have not watched that videos and if you want to watch that videos, or if you're curious about ERP, how it works, I'll have a link over here in the I button, or you can check the link in the description. Now coming to today's content, we'll cover introduction and why we need and how it works. So these 3 points we'll cover as part of the introduction. So let's start with the introduction. So DHCP. So the full form, we'll start with the full form. So it's basically dynamic host configuration protocol. So you can literally get the idea by the name that we are configuring a host dynamically, or you can say remotely. So it is used to assign a computer or a device its IP configuration remotely without anyone configuring it manually. So now imagine you have access point or router in your home, and we as a normal human being, we are not used to get the terminologies of IP address or MAC address and how those works. And let's assume that you are also not aware. Now every time, let's say you want to connect to internet, you need an IP address, that's for sure. So if you are watching this video, I hope you at least know that we need IP address to communicate over internet, right? So let's say we want to connect to internet, and every time, suppose we don't have this DHCP protocol as of now, and we have to configure IP address manually. So there are so many problems that you can get into, right? And nobody, and a layman won't have an idea about what is IP and why, what should be the IP address that I should give to my device so that I can talk to internet, right? So that is why we have this DHCP protocol, so that all those stuff we can reduce and we can configure the IP configuration manually, or not manually, remotely. So it is the first protocol that helps your device to onboard in local network. So as I said, that is the main purpose of having the DHCP protocol. And the last point as introduction is that it runs on the port number 67 for DHCP server and 68 for DHCP client. So whenever we want to get the IP address, our machine who doesn't have the IP address, and let's say your phone who might need an IP address, that can be fall under the DHCP client, because we want to get an IP address, and there might be a server, DHCP server, who will be responsible to provide us an IP address or other configurations. So that is main difference between DHCP server and DHCP client. So these are basically two processes that are running on two different devices. DHCP client will run on our machine which doesn't have currently the IP address, and DHCP server will run on, let's say, your access point or router or networking, any networking device, right? So those will have DHCP server process running, so that it can process the DHCP request packets and reply us accordingly with the configurations. So that's the basic idea of how DHCP works. So now coming to the main point, that why we need it. So let's get into the deep dive about how DHCP works and why we need it. We need to focus our discussion on two key concepts. So as I said earlier, automatic IP assignment, so that equals to reduce admin efforts or reduction in admin efforts. And the second point is no manual IP configuration. That means no human errors or no IP conflicts. So this might be a problem while we manually configure an IP. For your home network, it might be still fine, but let's say you have an entire enterprise. Let's say you have your college running, and you want to provide Wi-Fi internet connectivity or Wi-Fi connectivity to whoever present in your campus, right? Now to need to connect to your local network on your enterprise, or let's say in your college, you need an IP address. Now imagine you need to configure IP manually. Let's say you might configure this particular IP address 192.168.10.1, and you forgot and what was the last IP that you have assigned, and you by mistake somehow configure and same IP in another device. So that might lead to a human error, right? So these are the key concept that DHCP help us in solving, right? Now same way we can take a small example over here. Let's say this is your home router, the IP address is 192.168.10.100, and this is your mobile. Now let's say your mobile is connected and you have manually configured the IP this 192.168.10.1/24, and the gateway is this home router's IP. So that's the IP address over here, DNS and lease time. So now what is lease time, that we will talk later, but consider these are the IP settings that are given by DHCP server. Right now you don't have server, but you have configured this settings manually. Now let's say your friends come over to your home and they want to connect to your home router. Now what should this friend do if you are not present in your home, right? So they need to configure all these settings manually, but that might not be an easy solution. So this is the particular scenario where DHCP can help. Now let us discuss about the overview of DHCP. So DHCP works with the DORA process. So how it works is hidden in this term, which is called DORA. So it stands for discover, offer, request and acknowledgement. So now let's see what happens in each of the phases, and let's get the basic understanding about how DHCP works. So now let's see how DHCP works by understanding DORA process. So one of the first phases of DHCP is called discover phase. Now we'll take an example where this is your home router. This has a DHCP server running on its operating system or whatever the program that is running inside this home router, and it has this particular IP address. Now your mobile is here. It doesn't have currently IP address, but it does have the DHCP client process running in your mobile. Now the first process, when you connect to your SSID, let's say from your Wi-Fi settings you connect to your SSID. Let's say your SSID is XYZ. You try to connect to XYZ. So one of the first phase that DHCP will trigger is called discover. Now in this phase, DHCP client broadcasts the discover message in entire network, because right now your mobile doesn't know from where we need to get an IP address, because it doesn't know where the DHCP server is running. So it will send in broadcast message. Now consider this packet, and these are the header, Ethernet header for this packet, where source IP will be 0.0.0.0.0, because it doesn't have IP address currently, and destination IP will be broadcast. So all ones, that means 255.255.255.255, because we don't know what is the IP address where DHCP server is running, right? And source MAC will be DHCP client and destination MAC will be broadcast. So this will be the particular header for this packet. Now let's see what happens in the next phase. Now the second phase of DHCP is called offer. Now in this phase, DHCP server will unicast an offer message. Now offer message is kind of like when we request the IP, offer message is like here is your IP. Is that fine with you? It's like that. Now let's say in offer phase, your home router where DHCP server is running, they got the message that was sent by that was broadcasted by your mobile. Now it will process the packet and then gets to know that this is a DHCP request or discover packet. Now it will prepare and reply saying that all the details will be here. We'll see what all details this packet will include when we will explore the packet formats. But now let's understand just the communication. This packet will have all the information about what IP to be assigned, what should be the gateway, what should be the DNS, and every other stuff that is necessary, and this will be the header. So let's say source IP will be 192.168.10.100 and destination will be broadcast. Source IP will be home router's IP, destination will be broadcast, because DHCP server also don't know as of now that where your phone is, because your phone doesn't have any IP address, right? And source MAC will be DHCP server and destination MAC will be DHCP client, because in discover phase we got the source MAC of DHCP client, right? So now this will be the header of the packet, and this packet will include all the information about IP configuration and all those stuff that we need to connect our phone into our local network, which is served by home router. Now let's see what happens in the next phase. Now the next phase is called request phase. Now in this phase, DHCP client will respond with the request message saying that I will use this IP and your mobile needs an acknowledgement. So in this phase, your mobile DHCP client will send a request to acquire that IP address which was offered by the DHCP server, in this case your home router. Now this packet will have all the information about your mobile requesting the particular IP address. Now this will also be a broadcast packet, so source IP will be 0 because your mobile right now can't use the IP address that was offered by the DHCP server. It needs an acknowledgement by the server so that it can use that IP address. So that's why this packet header will also be including source IP as all zeros and destination IP as all ones, which is broadcast. Now source MAC and destination MAC will be client and server. So that's how the request packet header will look like. Now let's see how DHCP server will acknowledge this packet. So we are on to the last phase of DHCP process, which is called acknowledgement. Now in this phase, DHCP server will complete the process with acknowledgement message. So this packet will include all the information related to DHCP acknowledgement. It will have the IP information, lease time. We'll see what is lease time in next slide, but consider that alongside with the IP, gateway, DNS and all the other settings, there will be something called lease time. And the header of this packet will look something like this. It will also be in broadcast message. Source IP will be home router, destination IP will be broadcast, and source MAC and destination MAC will be respectively server and client. So that's how the acknowledgement packet header will look like. So while this DHCP DORA process was very simple to understand, there are so many complicated stuff working underlying the DORA process. We will see the packet formats to understand in the deep in next lecture, in next video. But here are a few terms that are important for us to know, such as the scope. So all the IP addresses which DHCP provides comes under the scope. Now let's say your home router is 192 using subnet which is having this particular IP address 192.168.10.100/24. So it can only assign the IP addresses that are falling under the subnet 10.0/24. So that is called scope of the DHCP server. So scope defines actually the boundary or limit that this device can give IP addresses to this many number of devices. So that is the scope. Now lease is equal to time interval for which your DHCP will lease the IP to the client. It's something like, let's say we are staying at some place, but we are paying in rent. So while paying in rent, you have been granted some lease to acquire that particular land. So it is like this only. Your mobile will not keep the IP address completely or forever. Your mobile will take the IP address on some time which is called lease time. Let's say your device will take an IP address for, let's say, 1 hour. So after 1 hour, the lease will be expired and your mobile has to renew the IP address. So we will cover in the next session, that how DHCP renew will be there. But you can remember that there will be something called lease time that will be included in the DHCP one of the DORA packets, and that is nothing but the time interval for which we reserve an IP address. And the next term is exclusion. So let's say from the scope, if we want to exclude some IP addresses, so those are nothing but exclusions. Now reservations. So to reserve an IP address for a particular machine, let's say your mobile has some MAC addresses that will be unique in entire, or you can say that will be unique globally. And now let's say we want to reserve an reserve an IP address for this particular MAC address, or based on some other policies, we can reserve some particular IP addresses for some machines. So from the scope only. So from this scope, let's say we want to reserve first 3 IP addresses or last 3 IP addresses, or mid or in between. Let's say if there are few IP addresses that we want to reserve, so that those IP addresses will not be allocated to any other devices. That's called reservation. Then DHCP relay. So this is a very important term for you to understand, because DHCP relay is nothing but a device that provides the facility to connect to DHCP server across different subnets. So let's say your home router and your mobile, those are in same network, but let's say we have multiple networks, multiple routers in between your mobile and the DHCP server. So DHCP relay will just transfer, or you can say forward your DHCP discover packet to that particular subnet. That is very important for us to understand, because without having an IP address, we can't route the packet or we can't broadcast the packet between subnets. So DHCP relay is very important for that purpose, and we'll also see how DHCP relay works. So yeah, these are the important terms that you should remember as a basic overview of DHCP. Now we will understand about the packet formats in next videos. But yeah, I hope you have got the basic understanding of DHCP, how it works and what's the DORA process. And yeah, that's it for today's video. We'll meet in the next one. Till then, keep learning and keep exploring.